Hello class, happy Halloween. Today what we're going to look at is something called Bboa. Okay, so let's dive off into that. Well, first thing is, what is Bboa? What does that stand for? Well, what it really stands for is the building blocks of algebra. There are 4 blocks that we look at, that we build everything in algebra on. 3 of those, okay, are 1, the expression, the algebraic expression. So if we were to look at this one, we know this expression says 2 times whatever x is plus 3. So that is one of the parts that's very important about algebra. Okay, now, if I know the expression, then that means I can create a T-chart for that expression, okay, which we now know just gives us a list of coordinates. So if I can build a T-chart, I can find some coordinates, which means I can now graph it and see the picture of what it looks like. Okay? So, and we know all of these are linear expressions, so we know they're all going to make a line. So that's 3 parts of the building blocks of algebra. Well, there is a 4th part, and the 4th part is actually creating a physical model, okay, where we use longs to represent our variables, and we use squares or unit squares to represent our constants. So the first part of this lesson is, how do I create a physical model of an expression? So let's see if we can do that. Well, we know that, remember, the longs represent our variables and the squares represent our constants. If they're open, it's positive. If they're closed, they're negative. So I need to model 3x plus 5. Well, 3x plus 5, well, 3x means I need 3 of these x values, and I need 5 of the unit cubes. So I'd pull out 5 of those. You can design however you want to. I like making little pictures, things like that. So here's a smiley face or an arrow, whichever the way you want to see it. Okay, so that's the model of 3x plus 5. And the reason why is we need to know how to do this is because sometimes they will give us models of an equation or models of an expression, and we have to interpret that. And that's the main reason why we do that. So what about negative 2x plus 3? Well, the negative 2x means I'm not going to use the open ones, I'm going to use the closed ones. So I need 2 of those. And then I need 3 open unit cubes. So there is negative 2x plus 3. Let's try another one. What about 5x minus 6? Now 5x minus 6 is kind of tough because you cannot model a subtraction problem because subtraction means to take away. So what we learned way back at the very beginning of the year is anytime we see a subtraction problem, we can change that subtraction to addition, next number to its opposite. Now that it's addition, I can model it. So this says I need 5x and 6 closed squares. And there would be the model of 5x plus negative 6. So let's try one more. What about negative x minus 4? Well, we know that anytime we see a negative x, if an x is by itself, we know that stands for negative 1x minus 4. Now again, what do we do with minus? We change it to addition next to its opposite. Now I can model it. So that means I've got 1 positive x, and 1 negative x, one closed x, and 4 closed units. And that's how we model an expression. Now, why are we going to do that? Well, today we're talking about something called Bboa. So we want to put all 4 of those pieces together. Okay, so in this particular example, I've given you the expression. So what I'd like for you to do is model for me that expression, then evaluate that expression in a T-chart, and then graph it so that we can see the 4 representations of the building blocks of algebra. So if we have x plus 5, that means we have 1 long and 5 units. Let me put those up in the thing and then rearrange those a little bit. So there we go. There is x plus 5. Now we know that x plus 5, this expression, we know it just goes right up here in the y value. All right? So we would put our x plus 5 for our y, and now we evaluate. So I take this x, negative 2, and I plug it in. Negative 2 plus 5 gives me 3. And then negative 1 plus 5 gives me 4. And then 0 plus 5 gives me 5. And then we look at our pattern. What are we doing? We're counting by ones. So then the next one is 6 and 7. And now we've created a set of coordinates that we can graph and look at our picture. So negative 2, 3 says I'm from the origin, I'm going to go left 2, up 3, and put a dot. The next one says I'm going to go left 1, up 4, put a dot. Next one says I'm going to go right or left none, go up 5, put a dot. Next one says right 1, up 6, put a dot. And then the last one says right 2, up 7, put a dot. So now to represent the whole expression, we do need to draw a line through it and extend out on both ends. And that's what that's what BBOA is all about. Making the connection between the model of an expression, the expression itself, being able to create a T-chart from this expression, and then graphing that expression. So let's do one more that's going to be like the assignment that we're going to have to do today. Because on the assignment, we're going to start at the model. I'm going to give you a model, have you create the expression from that model, have you create the T-chart from that expression, and have you create the graph from that T-chart. So here we go. Let's take a look. This expression right here, we represent it. Well, we know the longs represent our x's, and we know our squares, and this time they're closed, so it's going to be plus negative 3. Now, another way we could look at 2x plus negative 3 would be 2x minus 3. Means the same thing. Okay, on star, you will see it look like 2x minus 3, and we just know that we can change that to plus a negative. Now, we replace the y with 2x plus negative 3. We evaluate. So 2 times negative 2 gives you negative 4, plus negative 3 gives you a negative 7. 2 times negative 1 gives you negative 2, plus negative 3 gives you negative 5. 2 times 0 is 0, plus negative 3 gives us negative 3. So what is our pattern? We're increasing by 2. So this is negative 1 and then positive 1. And then we graph. Negative 2 says go left 2, and then negative 7 says go down 7. And then left 1, down 5. And then right or left none, down 3. And then right 1, down 1. Then right 2, up 1. And then we play connect the dots. And that's all there is to BBOA, the connection between the model, the physical model, creating an expression from that model, creating a T-chart from that expression, and then creating a graph from that T-chart. So until next time.